The objective today is to go over the control, transfer, and string instructions in the Intel Manual Chapter 5. We're on page 115. And before we get too deep, remember one of the strategies I was using to remember these assembly instructions is to write it out and then try to directly write what that mnemonic stood for. Sometimes it's one letter, sometimes it's three. But honestly, for me, remembering these was way easier than remembering all the keywords of high-level languages like Python and JavaScript, Java, C, C++. There's just so many of those. Sometimes I'd write a program and I'll use just the basic things I had remembered just to find out that I could write that program in like 100 less lines because there's just keywords for some of the things I was doing the long way. Maybe that makes me a natural for assembly. Maybe it just makes me an idiot who is not supposed to be programming in the first place. And I'll accept that too. I always tell my students I'm not very smart, but I will really work hard. And in the context of teaching, when I work really hard to learn something, usually I can make it easier to learn for others because I went through all that work. Okay, let's get started here though. So 517. Control transfer instructions. They provide jump, conditional jump, loop, and call and return operations to control program flow. So the question is, what do the control transfer instructions control? So JMP stands for jump. JE is jump if equal. You can also do jump if zero. A JNE, jump if not equal. And the same for the zero. Oh, I didn't notice these footnotes earlier in the last video, but I'll actually go over what this whole CPU ID semantics or syntax is. Don't be afraid, though, of that big, bad, scary line. All right, so we got jump if above, jump if not below or equal. Okay, I'm going to skip all those jump scenarios. I'm looking at JL here and thinking Justice League for my comic book fans out there. Now you'll remember that one, jump if less. Well, JC for jump if carry, not just kidding with a K. Okay, so jump if carry, jump if not carry, jump if overflow, not overflow. You see how this is just a pattern, a repeating kind of scenario. In almost each of our subgroups, it goes through the same kind of series. So I ask, what is the series of scenarios you should try to remember? And if I was you, I would say, like, remember that you have these comparators, greater than, equal, and less. You have your carries, you have your overflows, you have your negative and positive situations. Parity is even and odd numbers. That is really all you got to remember. You can control data and computers by using those scenarios. Well, here's something new for us. JCXZ is jump register CX0. Well, that must have been for the olden times because jump register ECX is probably more likely for you to see nowadays. So cool, you could create instructions for the program to jump to another section and start executing if ECX becomes 0. Some more newness right here. We got loop with ECX counter. Loop with ECX and 0, loop with not 0. A call is a call procedure, very simple. Ooh, and this might be the first time we see Intel using the full word of what it's supposed to be doing. Ret for return, iret for return from an interrupt. Int stands for interrupt, not integer. That's going to be important to remember. So I'll ask it in this way, what should int not get confused with? Interrupt should not get confused with integer. The instruction into stands for interrupt and overflow. The visuals I'm getting from that is funny. Well, we have this instruction called bound, which detects values out of range. And then to enter and leave, you're going to see this again. That is to enter a high-level procedure or exit a high-level procedure. All right, on to our string instructions. The string instructions operate on strings of bytes, allowing them to be moved to and from memory. Oh, I don't want to read all these. Let's see if I could do it really fast and maybe drive you crazy at the same time. Move SB will move byte string. Move SW will move word string. Move SD will move double word string. You can compare strings or compare a byte string. You can also compare a word string and also again with a double string. You can scan strings, scan byte, word, double word, and then you can load them, bytes, words, double words. You can also store them, no surprise. Alright, and our last three instructions. Repeat while ECX is not 0, repeat while equal, or repeat while not equal. So what's the difference between repeat and loop? Maybe a Stack Overflow question right there. And I'm asking, can we find these instructions in the wild? And actually, yeah, this one should not be so hard. Well, okay, that's it for today. Next time we'll talk about I/O. Remember how I just earlier said you'll be seeing the enter and leave instructions again? So that comes up in the next video. And then we'll, of course, do a lot of looking at the E flag instructions.